So good afternoon friends. So in last lecture we have seen the how to calculate the surface area of a cylinder. There are total two areas. First one is the curved surface area and second one is the total surface area. We just quickly revise the formula and we will going to solve the examples in today's session. So how to calculate the curved surface area. So in last lecture what we did, we did just one simple we did just simple activity, that is we have taken one cylindrical container, we wrap one rectangular paper over it, we cut the extra paper and we unwrap the paper. Now what we will get length as a circumference of that circle, and width is nothing but the height of that paper. So area of the rectangle is nothing but the area of the curved surface. So length is circumference, that is 2 pi r, and width is nothing but the height of the cylinder. So 2 pi r h is the curved surface area. Curved surface area equal to 2 pi r. And what about total surface area? In total surface area we have taken upper as well as lower faces. Both are circular in shape, so we just add two circular faces. So 2 into pi r square, we added this term 2 pi r square in the previous formula. So final formula for total surface area becomes curved surface area plus 2 times area of a circular faces, that is 2 pi r h plus 2 pi r square. So while taking common parts, 2 pi r in bracket, we are having h plus r as a remaining terms. So final formula for total surface area becomes 2 pi r into h plus r. Okay, so based on these two formulas, in this session we are going to solve some numericals. So let's start with first numerical. A water tank of a cylindrical shape has diameter 1 meter and height 2 meter. Okay, a tank is given with dimensions, diameter is 1 meter and height is 2 meter. A tank is closed with lid. Now see, this tank is cylindrical in shape and it is closed one. Okay, the tank is to be painted internally and externally including the lid. So what we have to do, we have to paint the tank completely from inside as well as outside, considering lid also. Find the expenditure if the rate of painting is rupees 80 per square meter. Okay, and value of pi is given as 3.14. Means we have to calculate how much expenditure is there, how much amount of rupees are required in order to paint this tank from inside as well as outside including lid. Okay, now see, the tank is to be painted internally and externally. Okay, what it means? It means that area to be painted is twice the total surface area, isn't it? We have to paint inside also and we have to paint outside also. The area becomes double. Okay, so the diameter of the base, which is given as 1 meter, so if the radius is half of that diameter, so radius becomes 0.5 meter, and height of the cylinder is given as 2 meter. Okay, so with the help of these two dimensions we can easily calculate total surface area of the cylindrical container. Okay, the total surface area of a cylinder equal to 2 pi r into h plus r. Simply put the values. 2 into pi is given as 3.14, which is constant value. R is given 0.5 meter, and in bracket h plus r is, h is 2 meter and r is 0.5 meter. So first solve in the bracket, then multiply all these terms. You will get, after solving bracket, you will get 2 into 3.14 into 0.5 into 2.5. So your final answer for total surface area of a cylinder becomes 7.85 square meter. Okay, now as we all know, we have to paint the tank internally as well as externally. So we have to double that area, as we already discussed. The area of the surface to be painted, which is equal to 2 into 7.85. So area becomes 15.70 square meter. With that, this much amount of area we have to be paint. And what they will what they ask you, they ask you expenditure of the painting. If the rate of painting is given 80 rupees per square meter. So for 1 square meter there is 80 rupees. Simply we have to calculate for 15.70 square meter how much rupees. Simply what I will do, The total expenditure of painting of the tank is equal to 15.70. This is the total area including internal as well as external surface. 15.70 into 80. So if I will multiply this, it will becomes 1256 rupees. So the total expenditure of the painting of the tank is 1256 rupees. So if I want to paint the tank from internally as well as external surface including lid, so I need 1256 rupees. Now see, this is the given problem. So what are the probable changes in this problem? So what is the scope, what I can change in this problem? For example, instead of paint internally, just I will paint externally. So what will be the expenditure? This will be the first change. Okay, second one, paint the tank internally as externally without lid. Someone says lid is not important, then without lid you have to paint internal externally. So in that sense, if there is no lid, so that means what, you have to calculate only curved surface area, no need to calculate total surface area. Okay, so be careful while calculating the area. Okay, once you have calculated the area, you can easily calculate the expenditure. Okay, because rate is given as per the square meter. Okay, so be careful while solving such kind of problems, though these are simple problems, but we have to be judgmental, isn't it? Okay, so in second problem we will proceed for second problem. I hope you are understanding. Okay, second one is a zinc sheet is of length 3.3 meter and breadth 3 meter. How many pipes of length 30 centimeter and radius 3.5 centimeter can be made from this sheet? Okay, a sheet is given which is of zinc material. The length of that sheet is 3.3 meter. Okay, note down the units carefully, and breadth is 3 meter. So how many pipes of length 30 centimeter? We have to draw the pipes from this sheet. We have to convert that sheet into pipes. So what they will ask you, how many such pipes whose length is 30 centimeter and radius is 3.5 centimeter can be drawn from this sheet? Okay, so now this is practical example. We are having, generally if we read somewhere, you must know from industry, from steel industry or from many metal industry, material comes out as a sheet. Okay, so we have to convert it into pipes or cylinders or whatever or the tank as per our requirement. Okay, now in that case we must know the basic formulas. This is the practical application. Okay, now area of the rectangular sheet, that is zinc sheet, is nothing but the length into breadth. Length is given as 3.3 meter and breadth is given as 3 meter. So your formula becomes and simultaneously what I am doing, I am just converting this meter into centimeter. So 1 meter is 100 centimeter. So 3.3 centimeter becomes 330 centimeter and 3 meter becomes 300 centimeter. So my answer becomes area of the rectangular sheet is 330 into 300 square centimeter. Okay, again I am not doing calculation completely, I am just putting the answer in multiplication format as it is, because it will help me to for calculation, for further calculation. Now in order to convert that sheet into pipes, the required dimensions of the pipes are 30 centimeter length, 30 centimeter is length, required length, and radius must be 3.5 centimeter. Okay, so what I will do, so length of the pipe is same as height of the cylinder. Okay, because we have to roll that sheet, so length becomes height of the cylinder, which is equal to 30 centimeter, and radius of the pipe is nothing but the radius of the base of the cylinder. So radius of the base of the cylinder given is 3.5 centimeter. Okay, we have to closely observe what I am going to change. Okay, in this case I am going to convert sheet into pipe. isn't it? So whatever the length of the pipe, if I will open it, it is equal to height of the cylinder, which is given as 30 centimeter. So radius of the pipe is base of the cylinder 3.5 centimeter. Now the sheet required for a pipe, which is nothing but curved surface area of one pipe. Now you can easily calculate curved surface area. Formula we have with us, that is 2 pi rh equal to 2 into pi is a constant. Either you can take 22 by 7 or 3.141 and the same thing. Now radius is 3.5 centimeter. I am going to convert this centimeter. Not necessary to convert, just write down in simple format. 3.5 centimeter equal to 35 divided by 10. I just shift that point, okay, towards the right, so that there is a 10 in denominator, so it becomes 10. Similarly, height is equal to 30, so 30 by 1, there is no need to change. So your for after calculation, what you will get, 2 into 22 into 15, your answer becomes 660 square centimeter. Okay, so one thing you have to calculate you have to perform these calculations, okay, while you are practicing, while you are doing your homework. Because see what happened, I am just going to explain here. I'm not able to calculate here. So this is your homework. You have to just cross check the answer, whether these answers are correct or not, isn't it? Okay, so the sheet required for a pipe is of 660 square centimeter. Now if I want to calculate the number of such pipes, then formula becomes number of pipes made from the sheet, which is equal to area of the sheet divided by curved surface area of the pipe. So both areas are with us. So area of the sheet is 330 into 300 divided by curved surface area of the pipe is 660. Both units are same, square centimeter. So after simplification, what I will get answer as a 150. So from the given sheet, whose material is zinc and dimensions are 3.3 meter into 3.3 meter into 3 meter, so I can drawn 150 pipes of the as per the requirement, that is whose length must be 30 centimeter and radius must be 3.5 centimeter. See here the problem is simple. You are going to apply the formulas, but one thing you have to remember, the length of the pipe is same as the height of the cylinder, and the radius of the pipe is same as the radius of the base of the cylinder. Okay, once you will know this, you can easily calculate the answer. So from the zinc sheet of given dimensions, you can draw 150 pipes. Okay, so we'll proceed for third one. Okay, so these two problems I just take here. You can solve as many as you can, as per your standard notebook. Okay, now this is all about surface area of a cylinder. So surface area includes two areas, curved surface area and total surface area. Okay, so with the help of these two examples, I hope you are clear with this. Okay, next and last part of this chapter is a volume of the cylinder. Okay, as we all know the basic definition of volume is nothing but the measure of the space occupied by that solid geometry. So in this case it is a cylinder, so volume of cylinder is defined as the measure of the space occupied by the cylinder is known as volume of the cylinder. And to find how much water a tank of a cylindrical shape can hold, we have to find the volume of the tank. This is the practical application. Why we are calculating the volume of the cylinder? So if we are able to calculate the volume of the cylinder, we can easily calculate how much water a tank of a cylindrical shape can hold. Okay, now common formula for volume, see, any for any geometry there is a common formula for volume, which is equal to area of the base into height. So this is generalized formula. So area of the base into height. Now in case of cylinder, base area of a cylinder is circular. Base is circular in shape, isn't it? Cylinder base is circular in shape. So base of a cylinder is circular, then area becomes pi r square, area of a circle, isn't it? And height is h. So you simply, your formula for volume of a cylinder becomes pi r square h. Are you getting? Pi into r square is the radius of the circle. Why I am taking radius of circle? Because base of the cylinder is in circular shape, isn't it? And height is h. So formula for final formula becomes pi r square h. Okay. So with the help of this simple formula, we can calculate the volume of cylinder. So we are going to calculate number of problems, so that you will come to know, you all are clear with this concept, that is how to calculate the volume of cylinder. So we will proceed for first example. Find the volume of a cylinder whose height is 10 centimeter and radius of the base is 5 centimeter. See, always read the problem carefully. So what you have to find out, because see, in examination you have to solve the complete problems. It may be cube, it may be cuboid, it may be cylinder. You have to calculate curved surface area, you have to calculate total surface area, or you have to calculate volume. So unless and until you will read the problem carefully, you cannot solve the problem in a perfect way. Okay. So first problem is find the volume of a cylinder. What they will ask you, you have to calculate volume of a cylinder. So simply height is given 10 centimeter and radius of base is also given 5 centimeter. The standard pi value is 3.14, as we all know. So radius of a base of a cylinder is 5 centimeter and height is 10 centimeter. So volume of a cylinder as per the formula is pi r square h. Simply put the values in the UN formula. Pi is 3.14, r square is 5 square, and height is 10 centimeter. So 3.14 into 25 into 10 becomes 785 centimeter cube, or 785 cubic centimeter. Okay, simple formula, simple problem. So instead of radius of the base, most of the times they will give you diameter of the base. What you have to do, you have to just convert the diameter into radius, simple way. Okay, now moving towards second problem. Height of the cylindrical drum is 56 centimeter. Find the radius of the drum if the capacity of the drum is 70.4 liter. Now they gives you height of the cylindrical drum as 56 centimeter, and the capacity is also given. Capacity means again volume of the cylinder, which is given as 70.4 liter. So we have to find out radius of the base drum, radius of the drum particularly. So radius of the drum, if we assume, let's start with unknown parameter. We are on the most important step. If I want to calculate radius, what I will do, I will assume radius as a first step. I assume radius as a r. Let the radius of the cylindrical drum be r. Okay. Now capacity of drum, as we already discussed, capacity of the drum is nothing but volume of the drum, which is given in liter. Okay, 70.4 liter. So as we all know, in previous session we have seen 1 liter is equal to 1000 cc. So similarly 70.4 liter equal to 70.4 into 1000 cc. So this is nothing but the volume of the drum. Okay, because 1 liter equal to 1000 cc. So volume of water, again you have to use same formula, pi r square h equal to volume is given 70, after multiplication 70.4 into 1000 becomes 70,400. So just put the value 70,400. So pi and h is with us, so it is in multiplication, it will be in dividation. So you will get r square as 70,400 divided by pi into h. So 70,400, pi is given as 22 by 7. So this 7 in dividation becomes likewise a by b by c, which is equal to a into c divided by b. In the same way, this 7 comes in numerator. So your answer is 70,400 into 7 divided by in denominator 22 and 56 remaining. So we have to multiply them. So final simplification is 70,400 divided by 22 into 8. I just divide the 7 and 56. So 7 1s are 7, 7 8s are 56. So 8 is here. So finally 8800 divided by 22 is remaining, which is equal to 400. So r square is 400. We have to take square root. So 400 is a square root of 400 is 20. So r becomes 20. So this is what, this is the radius of the drum. The radius of the drum is 20 centimeter. Either they will ask you to find out radius of the drum, or they will ask you find out the diameter of the drum. Okay, so if radius is, if they will ask you diameter, if radius is 20, you can simply calculate the diameter. Or there may be a one change, they will also ask you to calculate the height of the drum if radius is provided. Okay, in the same way you have to calculate. The most important thing is what, you have to convert the unit. If you put the unit as a liter, so you are not able to calculate, because liter is what, liter is the volume of the liquid, liter is the unit of volume of the liquid. You have to calculate the volume of the liquid is equal to volume of that particular container, but unit is different. So you have to convert that liter into centimeter cube, that is cubic centimeter, by multiplying by 1000. So there and then only you can easily calculate this. Okay, so these are the some of the changes which you have to be care while solving the further problems. Okay, so we will see one more problem which is more interesting, and this might be a last problem of our session. The radius of the solid copper cylinder is 4.2 centimeter and its height is 16 centimeter. How many discs of diameter 1.4 centimeter and thickness 0.2 centimeter can be made from the cylinder melting it? Okay, see again one more practically point of one more problem which is practically which dealing practical application, which dealing in important application. So there is a copper cylinder whose base radius is 4.2 centimeter and height is 60 centimeter. From this copper cylinder, what we have to do, we have to cut from this copper cylinder we have to cut the discs. Such requirement is what, whose diameter is 1.4 centimeter and whose thickness is 0.2 centimeter. So we have to find out how many discs can be made from this cylinder. So we have to just cut the cylinder of the required in the form of disc of the given dimensions of the disc, so that we have to find out how many discs are made from this cylinder. Okay, see, radius of the base of the cylinder is given as 4.2 centimeter. See, as there are two dimensions here, first one is the radius of the cylinder and second one is the radius of the disc, and similarly height of the cylinder and height of the disc. So what I will do, for radius of the base of the cylinder I am using notation capital R, and for the radius of the base of the disc I am using small r. Okay, so it will be easier for us. So radius of the base of the cylinder is 4.2 centimeter and height of the cylinder capital H is 16 centimeter. So volume becomes pi into capital R square into capital H. All formula are, all dimensions are with us. Pi, I will remain pi as it is because it will be easier for me for further simplification. Pi into R square is 4.2, which is 4. I will just write in R square equal to R into R format. So it becomes 4.2 into 4.2 and H is 16. Okay, now radius of the base of the disc is given as diameter is given as 1.4 centimeter. So radius becomes 1.4 divided by 2 is 0.5 centimeter, and height of the disc, which we also called as the thickness of the disc, is a 0.2 centimeter. So volume of the disc is pi into R square H. See, why I am calculating these volumes separately, because I have to calculate number of discs. So if I will divide the volume of the cylinder to the volume of the disc, so I will get total number of discs. So first step, I calculated volume of the cylinder, which is pi into capital R square into H, and I just wrote in a multiplied format. I didn't calculate it, okay, because it will be easier for me, okay, while calculating. And similarly, volume of the disk become pi into small r square into h, which is equal to pi into 0.7 into 0.7 again. R is r square equal to r into h. H is given as 0.2. So total number of disks equal to volume of the cylinder divided by volume of the one disk, which is equal to pi r square is divided by pi into capital R square capital H divided by pi into small r square small h. Now here the reasons comes out why I didn't put the value of pi and multiply, because both in numerator and denominator this term is common. So instead of writing down and doing calculation, what I will do, I will just cut it down, because both values are same. Whether you can take 22 by 7, whether you can take 3.4, both values gets cancelled out, and you will be and in numerator you will get r square into capital R square into capital H, and denominator you will get small r square into h. So formula is for r is 4.2 into 4.2 into 16. R square is written as r into r in both and numerator and denominator. Capital R, remember capital R is the radius of the base of the cylinder, and small r is the radius of the base of the disc. Small r is used for radius of the disc, capital R is used for radius of the cylinder. So I will just write down 4.2 into 4.2 into 16 in numerator, and denominator 0.7 into 0.7 into 0.2. So finally 42, it becomes 42, it becomes 42, 4.2 becomes 42, because I am just shifting the points same from numerator and denominator. 4.2 becomes 42 and 0.7 becomes 7, okay. And this will be the easy steps for calculation, or you can use any method as per your convenience. Not necessary you have to follow the same step, you can use any method for convenience, but in order to save the time I am just select this method, okay. So it becomes 7 6 are 42 and 7 6 are 42, and 2 160 divided by 2 becomes 80. So 6 into 6 into 80 becomes 2880. So this much amount of discs, that is 2880 discs, will be made from the cylinder. So when I will use this complete copper cylinder to make the discs, so to near about 2880 discs can be made of the required dimension. So this is the practical application, and it may be necessary that discs, the final product may be discs. So as per the industry requirement, so they can convert. It may be possible that disc is of different dimension, cylinder is of different dimension. For just for understanding, when I have to calculate number of disc or number of pipes, what I will do, I have to divide the volume of the major part divided by the volume of the minor part, okay. So this is all about the surface area and volume. So this is the content, basic content, which we can use for basic information for the your 10th standard chapter surface area and volume, which is included in CBSE board, and which is most important again. I hope you will understand. In this particular session, what I will focus, the surface area and volume of a cylinder particularly, okay. Surface area of cylinder includes total surface area and curved surface area, and volume of the cylinder is nothing but the area into height. So with the help of these formulas, now one more interesting information is with us, just for information. This is not in your comes in your examination. See, Leonard Euler, a great mathematician, and discovered an interesting formula regarding faces, vertices, and edges of the solid figures. So here one small exercise for you. Definitely I will help you. Count and write the faces, vertices, and edges of the following figures and complete the table. From the table, verify Euler's formula. F plus V equal to E plus 2, where F is what? Faces, V is vertices, and E is edges. So simply they just give you various solid geometries, and you have to complete this table. For example, shapes are given. First shape is cube and faces are 6, vertices are 8, and with the help of this Euler's formula f plus v equal to e plus 2, you can calculate the remaining part. That is, in first case, in case of cube, if faces are 6, vertices are 8, so it becomes 12 equal to e plus 2. So e must be, so 12 minus 2 becomes, sorry, 6 plus 8 is not 12, 6 plus 8 is 14, 14 minus 2 is 12. So instead of so here at the blank space in front of ages, you have to put 12 as your answer. Are you getting? So either you have to calculate faces, vertices, or edges. And in second shape, there is a cuboid. Again same, see, cube and cuboid are the same things. Okay, only the difference is what length, width, and height is different. So if I want to know faces, if I want to know vertices, these are same. 6 faces are also there for cuboid, and 8 vertices are also there for cuboid. We can just check it and just cross verify the formula. Now in third case, triangular prism, if we closely observe, you will get total 5 faces are there and 6 vertices are there, and total edges are 9. So that so your Euler's formula can be satisfied. That is, LHS equal to RHS. 5 plus 6 equal to 11, and 9 plus 2 is also 11. Okay, edges are 9. So here your answers are 5 in first row. First part, faces are 5, vertices are 6, and edges are 9. Similarly, for triangular pyramid, faces are 4, vertices are 4, and edges are 6. So that this Euler formula can be satisfied. Fifth one is pentagonal pyramid. For pentagonal pyramid, if we measure carefully, the total faces are 6, vertices are also 6, and edges are 10, which is given. Okay, so that Euler's formula is specified. And last, hexagonal prism, there are 8 faces which is given, 12 vertices also which is given. So you have to just put the values. LHS becomes 20. In order to RHS becomes 20, what I have to put? I have to put edges as a 18. Okay, you will get as a 18. So this is somewhat interesting information, so which is known as Euler's formula, which is most important formula. Okay, so I hope you will understand. Thank you.